So here is the reliability test. So from that, from the title, what we can see, reliability test, something similar to reliable. So it is important to do the reliability test before analyzing the data. Because I'm just giving you an example. If there is an opportunity to invest money to any sort of source, to any particular source, what we will do first? We are concerned about whether that organization or that source is reliable or not. Because if the source is not reliable, there is a high chance of being cheated. And similar like that, our questionnaire is the measurement is our research tool. Okay, so if there is any error, if the research tool is not reliable, then our analysis, there is a high chance of being corrupted. Okay, so if it is not reliable, what you have to do, you have to collect the questionnaire, you have to collect the survey again, you have to contact the survey and collect the response again. So reliability refers to the consistency of the measures. Measures in the sense of measurement items. And there is so many ways to the reliability test, but the widely known and used is convex alpha. It is the most common measures of internal consistency. Internal consistency is the another, you can say the similar of reliability. Okay. So the next line is, it is most commonly used when you have multiple Likert question in a survey questionnaire that form a scale and you wish to determine if the scale is reliable. That's what I'm saying. As we have adopted a 5-point Likert scale, so it is important to check whether that scale is reliable or not before proceeding the data analysis. And we will be using convex alpha for checking the reliability of the variable. So the alpha value will be 0 to 1. And many authors, many researchers have categorized those value into so many categories, but you have to pick a genuine one. Not everyone is genuine actually. Those are proven, but there are some authors, there are some sort of measurement. Those are widely accepted, widely used. So you will get all those things from Google Scholar. If you just go through the papers, you'll get to know about the accepted value. So here I have pasted a picture. The left hand side, it is showing the alpha value, convex alpha value, and in the right hand side, it is showing the internal consistency. So that slide is showing that if the alpha value is less than 0.5, that is unacceptable. In that case, you have to recollect the response from the respondents. You have to collect few more response. You can check again. If it is still unacceptable, you can conduct few more survey. And the value between 0.5 to 0.6 is poor. So you will follow the same thing, the same procedure for increasing the reliability. Then the third one is questionable, and the value will be range between 0.6 to 0.7. And most of the researchers, they have agreed that the alpha value more than 0.7 is acceptable, and the acceptable range is 0.7 to 0.8. And the alpha value is, the range between 0.8 to 0.9 is good, and the value more than 0.9 is excellent. So let's have a look. Wait, let's check it whether our reliability is good or not. So again, we have to go to the SPSS, and here click on analyze in scale. Okay, in scale there is option named scale. There is option in scale there is option that is reliability analysis. Just click on that. That bar tab is so annoying. Look, here there are 9 items for VP1, VP2, and VP3. It belongs to a single variable. SQ1, 2, and 3 does belong to another variable. RI1, RI2, and 3 does belong to another variable. So we will be doing it, stepwise. First, we will be checking the reliability of the VP1, 2, and 3. I mean, the variety of the product. Just click on statistics. If you required anything, you can click on that and just click on option that is called scale if item deleted. I mean, if just click on the I will be explaining. Okay, so I think we don't need any other thing from here. Okay, to continue, just click on OK. So here we can see that our reliability statistics, our convex alpha value for 3 items is 0.862. So 0.862, which is more than more than 0.8, and the range between 0.8 and 0.9. That is 0.8 and 0.9 is good. That means our questionnaire, the items of the questionnaire, items of our study, they're having a good internal consistency and good convex alpha value with good reliability. But we have clicked on another option, that is if the item is deleted. Scale means if the item is deleted. So just ignore the first 3 part. Look at the the 4th one. So it is showing that for BP1, if I delete that item, the convex alpha value will be 0.70. That means here our value is 0.862, but if we delete that, our point will be decreased. So it will be 0.70. So we can't delete that value. It is important. Similar, like if we delete the BP2, the alpha value will be 0.814. It is also decreasing the value of our reliability. And the third one, BP3, if we delete that item, the value will be 0.834. So here we are having, that our original convex alpha value is 0.862, the current one. But if we delete any of items from that variable, the alpha value will be decreased. So all those variables are very important. We can delete, but sometimes, I have only taken only 3 variables, but you will get that researcher will take not three variables, actually three measurement items for each variables. The researcher usually take 5 to 6, 7 measurement items while conducting the survey. So that time they can delete based on that value. So we don't have to delete as our value is 0.86. Another thing, if your measurement item is more than, if there is too many measurement items, that time also, if you want to delete that, you can delete any of the measurement item based on that value. So let's check the reliability of rest two values, two variables. Just click on reset, everything will be removed, and select SQ1, press on control, SQ2, SQ3, and click here, same, click on statistics, click on scale, if item deleted, and OK. So here, SQ means that service quality. So service quality, the convex alpha value of service quality is 0.823. That means that is also a good value. Okay, the reliability is good. But if you delete any item, whether it is SQ1, SQ2, SQ3 from that variable, service quality, the alpha value will be decreased. If we delete the first one, the value will be 0.806. If we delete the second one, the value will be 0.766. If we delete the third one, the value will be 0.697. So here we can't delete any of the items because every item is very important for our study for that particular variable. Let's check the reliability of repurchase intention. Go to scale, click on reliability analysis, reset, select R1, RI1, press on control and click RI2, RI3, click on statistics, scale. If the item deleted, click on that, click on continue, or click on OK. So the convex alpha value of that variable is also 0.823. So here is the value, as you can see, 0.823, and n of items. It means the number of items. There are 3 items, R1, R2, and RI3. So total number is 3. And from that also we can say that if we delete the first value, items, the value will be decreased. If we delete the second items, the time also the value will be decreased. If we delete the third items, the time also the value will be decreased. So there is no option. We don't have any option to delete any of them. But in your study, how you will interpret? Okay. So that was the value for variety of products. So you have to just make a table and put the variable name in the left and that value in the right. Okay. So the value will be 0.862, and for service quality, the value will be 0.823, And for repurchase intention, the value will be 0.823. Okay, and you will be interpreting by following that accepted value. I mean that one. Though you have to give the justification and citation as well. You have to do the referencing as well.